Lecture 8.2, Day 2, Identifying Indeterminate Forms. What makes an expression indeterminate? Consider infinity over infinity. We can hold one part of the expression constant. For example, we could take the limit as x goes to infinity of x over 1,000, and we get infinity. But if we take the limit as x goes to infinity of 1,000 over x, we get 0. There are conflicting trends here. The actual limit will depend on the rates at which the numerator and denominator approach infinity. So we say that an expression in this form is indeterminate. Let's look at another one. Consider infinity to the 0. We can hold one part of the expression constant and take the limit as x goes to 0 of 1,000 to the x, and we get 1, because any number raised to the 0 is 1. However, if we make the exponent a small number close to 0 and take the limit as x goes to infinity of x to the 0.1, we get infinity. On the other hand, if we make the exponent a number close to 0 but negative, for example, we could have the limit as x goes to infinity x to the negative 0.1, and we get 0 because the negative exponent flips it over, and we end up with a fraction with a large denominator. Once again, we have conflicting trends, so this form is indeterminate. Finally, here's an expression that looks like it might be indeterminate. Consider 0 to the infinity. We can hold one part of the expression constant. For example, the limit as x goes to infinity of 0.1 to the x is 0. If we make our constant negative 0.1, which is also close to 0 but negative, and take the limit as x goes to infinity of negative 0.1 to the x, we still get 0. Or if we take the limit as x goes to 0 of x to the 1,000, we get 0. The limit is 0 any way you look at it, so the expression is not indeterminate. Here is the standard list of indeterminate forms. 0 over 0, infinity over infinity, infinity times 0, infinity minus infinity, 1 to the infinity, 0 to the 0, and infinity to the 0. There are other indeterminate forms using complex numbers, but those are beyond the scope of this class.